architecture. Here you can see a hierarchical structure with 3 layers. The bottom layer is the computing engines for Hive. And once again, Hive supports Test, MapReduce, and Spark, but by default, it uses Test to do analysis. The central layer is called Driver, which is the brain of Hive. All the tasks are just processed in this driver. But from the graph, you might have found out that the driver could be divided into 3 parts: compiler, optimizer, and executor. Indeed, we have mentioned this before. Since the user writes command via HQL statements, compile the HQL statements into test or MapReduce or Spark jobs, and that is exactly the responsibility of the compiler. But maybe the jobs are not in a good order, or maybe they have many unnecessary computations, so Hive needs the optimizer to optimize the workflow. And after optimizing, Hive uses the executor to execute all the jobs by the relevant engines. And on the right, we can see the metastore, which stores metadata of tables, like table name, table size, and so on. And on the top, there are several interfaces, as mentioned before. So here, we won't explain again. The running process of it looks like this. Please have a look if needed, and Yum will be introduced in later chapters as a resource allocation and management platform which allocates CPU and memory for different computing engines. Next, we are going to introduce the data storage of Hive. Just like many relational databases, there are concepts such as database and table Hive as well, but the fundamental storage has many forms, such as bucket and partition. The differences between them will be used in the next page. Now, look at the right part of the graph. We can see 2 types of data: skewed data and normal data. What's the difference? If a Hive table has 1 million records, while the ratio of men to women is roughly 1:1, now we consider this data as normal data. But if a ratio is 10:1 or even 100:1, then we call it skewed data. Skewed data may lead to wrong analysis results, and we must pay attention to it carefully. And in fact, we can simply use partition or bucket to deal with this problem. Now it's time to introduce partition and bucket. Generally speaking, both partition and bucket are used to divide Hive table into several small segments, and thus we can improve the reading and the writing efficiency. But there is a basic difference between them. Firstly, for partition, we make the division by different directories. In this case, the table is still an entirety, and since making partitions is just creating some new directories and updating the metadata, it is cheap, and the partition number is not fixed. Namely, the partition number can be changed, and further partition or even buckets can be created in a partition. However, things are totally different for buckets. Here, we say that each bucket is a physical file. Namely, we have actually divided the big table into several small tables in a physical way. So it requires many resources, and thus the number of buckets needs to be specified when creating a table, and could not be modified later. Okay, maybe you're wondering, When should I use partition? To take an example where partitions are commonly used, imagine log files where each record includes a timestamp. If we partition by date, then records for the same date would be stored in the same partition. Queries adding restrictions to a particular set of dates can be answered much more efficiently because Hive only needs to scan the files in the same partitions. And when shall we use bucket? There are two reasons. First reason is similar to making partitions, to make querying more efficient. Bucketing imposes extra structure on the table, of which Hive can take advantage when performing searching queries. The second reason to bucket a table is to make sampling more efficient, and we can use bucket to make a better usage of the skilled data. Okay, apart from the data storage model of Hive, the two concepts of manager table and external table introduced in this page are vital for Hive as well. Remember, in the first section, we mentioned that Hive decouples the metadata and the user data, so it is more flexible than the traditional data warehouses. And thanks to the decoupling, we can define a table either managed by Hive or read from external locations, and that is the basic difference of manager table and external table. To be more specific, in a manager table, both the metadata and the user data are managed by Hive, which means that the user data should be moved into the user Hive warehouse directory on HDFS. And if we job the manager table, both metadata and the user data will be deleted completely. But for external table, Hive just creates the metadata as a mapping directed to the user data. But the user data is remained on the location where it used to be. And now, if we job an external table, only the metadata will be deleted. The user data will be preserved. But how to choose which type of table to use? In general, if you are doing all the processes with Hive, then use manager table because it is more efficient. But if you wish to use Hive and other tools on the same dataset, then use external tables. Quite clear, right? And just as mentioned before, Hive supports many built-in functions as well as user-defined functions, or UDF in short. Actually, not only UDF, but also UDAF and UDTF, where A means aggregation and T means table generating. So quite literally, a UDAF receives many records and generates just one result, such as sum, max, min, etc. While a UDTF receives just one record and generates multiple rows, like explode, stack, or inline, etc. You can define either of them with Java and use the functions to do many complicated jobs. Okay, just a very brief overview of the functions and architecture of Hive. Next, in the third section, we can have a look at how can we use Hive to do the ETL and to do data analysis.